been working with Oracle since '97, almost 23, 24 years now. Doing mainly SQL for the clients. I started working with PL SQL since '99, and I've been doing that ever since. And I've been making a living doing SQL and PL SQL for the last 20 years. I started playing with Apex a little bit in 2003. I started presenting in 29. I became an ace in 2011. I became Oracle Developer. I got the Oracle Developer Choice Award in 2015. And last year I was promoted to become an ace director, mainly because I talk a lot. I do some blogging. Actually, I blogged yesterday for the first time since forever, a couple of months, I think. I wrote some articles for All Things Oracle, but they disappeared. But I found the new location of these articles on the link you see here. I also had my own column in the OTech magazine, but OTech magazine stopped appearing, so I put the articles on my own blog. These are my contact details. I will send out a PDF of the presentation after, probably somewhere this week, so you can download that. Like I said, I've been an ace for a little over 10 years now. Yeah, almost 10 years now. If you want to know more about the ACE program, go to the bit.ly link here. And if you want to become an ACE or want to nominate somebody else, go to the ACE nomination link over there. Yeah, you probably don't want to nominate yourself because it's actually a bit like, I don't have any friends and want to be with the club, so please make me an ACE. Get somebody to nominate. You've probably all heard of this. Oracle offers the free tier, the free cloud solution. This gives you 2 autonomous databases, either data warehousing or transaction processing, with 20 gigs of storage each. You can create 2 compute VMs. You've got a lot of block storage, etc. And it's going to be free forever, as long as you log in every week, I think. But we're developers, we know how to script that. So, topic of this afternoon, a gentle introduction to polymorphic table functions. Picture this, it's 2017, Oracle Open World. Oracle is just about to release Oracle version 18. And a colleague of mine went to the Open World seminar, and he came back and asked me, could you please tell me in Tom and Jerry terms what polymorphic table functions are? Because I know database stuff. And my reply was, are you out of your mind? The ANSI documentation alone is a 200-page document. I started reading it and I got lost at page 2, I think. But it did make me think, what are polymorphic table functions anyway? And what do you do when you don't know what something means? Well, I'll go sit down on my computer and I'll go to Google, because Google knows everything. Well, at least they help you with a lot of things. It taught me that polymorphic table functions, well, polymorphism comes from Greek words. Poly meaning many, like polygon, many corners, and morph meaning form, morphology. So actually it's many different forms. But we've been doing that for like forever. We got one database, or nowadays you got a container database with different pluggable databases, same concept, multi different forms. You got different users in there, different schemas, but even within a single schema, you got the object table. And a table can have 6 columns, 5 columns, 3 columns, 100 columns, whatever you want. So it's the same object with different forms. But even a table can be displayed as different forms using views, where you can display like 3 columns or 5 or the entire table. So actually, we've been doing this for like forever since Oracle 2. Back to the question. Can you tell me in Tom and Jerry terms what polymorphic table functions are? Well, if you go look into the characters, what do these characters have in common? They're all cartoon characters. They're animals. And they all speak. Well, in the cartoon, they speak. And let's implement some code to display how they speak. Let's do that in English because that's the easiest way from. Let's say Tom says meow, Jerry says squeak, and Spike says woof. Going into polymorphism, I found out there are 2 different kinds of polymorphism. First, there is static polymorphism. At static polymorphism, at compile time, the compiler decides which piece of code is going to be run. So if we create a package with a couple of procedures, in this case 3 procedures overloaded, same name, different variable names, different parameter names, and the compiler resolves at compile time which procedure it's going to call and which it's going to execute. For the implementation of the procedures, we have pretty much the same lines all the time, except for that we use a different parameter name and we use a different output. So when I run this, when I compile this piece of code and I run this, I'll get the output as shown on the screen. Tom says meow, Jerry says squeak, Spike says woof. That's static polymorphism. Dynamic polymorphism, on the other hand, is when the compiler doesn't decide which piece of code. At runtime, the runtime engine decides which piece of code to run. We can do this by using the Oracle object types. We create a type in the database with a name and a member procedure, speak, final, and then for all the 3 characters we're implementing, we implement a child type under the parent type, overriding the member procedure. So we create a type Tom, we create a type Jerry, and we create a type Spike. As you can see, they're pretty much the same except for the name and what their speak is. If I run this, I can use a single variable of the parent type, and then at runtime, I'll say the Tom and Jerry variable is now a Tom type, and I'll call the speak function. And then it's a Jerry type, and I'll call the speak function. These lines are exactly the same, and for Spike, exactly the same as well. And I get the output as I expected. But then there's somebody coming in and says, hey, there's more characters to the Tom and Jerry and Spike. There's also the little quack. He says quack. Well, we can easily implement that using the object type. We'll just build another subtype, the little quacker, and implement that one. So then we can just execute pretty much the same code, except for we add the little quacker here, and we get the results as expected. But it means that every time I change or my data change or my requirement change, I have to change the code. What if we would do this using a table function? Let's create a table, Tom and Jerry, and insert Tom, Jerry, and Spike there, just to start up with the first 3 characters. Then we create a database type, Tom and Jerry, which is pretty much the same as the row type in the table. And we create a table type, a nested table type for the Tom and Jerry. Then we can create a package with the function speak, returning the Tom and Jerry table type. And the implementation will be, it will select all the rows from the Tom and Jerry table, and it will return the different speaks, the different rows one at a time. And if I select name, says, and then the sound, it'll show me the 3 different rows. If I then insert another row into the table, a little quacker, and I run the exact same query again, select name, says, sound, it'll show me the new sound. So when my data changes, I don't have to go back into my code to reflect these changes. Then someone came up and says, yeah, that's nice doing it in English, but you're Dutch. Can you do it in Dutch as well? Let it say meow, beep, bluff, vec. Well, if we do this using the table functions, we alter the table, we rename the sound column to English. We'll add a column for Dutch, and we'll update all the columns or all the fields in the rows to implement the Dutch versions. And then after that, I'll have to change the, if I call the same query again, it says, well, my package body has errors. That's correct, because my type is no longer the same, and my table is no longer the same. So I have to change the type to reflect the correct fields now. And if I'll ask it to say name says English, I still have errors in my package. So I'll have to go back into my package and make sure that the cursor is correct here. And then after that, it does what it's supposed to do. And I can select name says English or name says Dutch using the same code. But I had to change my code to reflect this new column, this new possibilities. And then after this was done, somebody came up to me and says, well, you got it in English and Dutch, you can probably do it in Spanish as well. remember, this was end of 2017, starting 2018. It is an 18C feature. I had no access to the Oracle database at 18C by that time. But what we did have is the database in the cloud. We have LiveSQL. LiveSQL gives us pretty much the most recent version of the Oracle database. I think it's now 19.8 running on the livesql.oracle.com. On LiveSQL, you got a complete schema to play with. Be aware though that if you log off, your schema will be gone. So it's not persistent like in a normal database. You can create tables, views, procedures, functions, packages, whatever. And the good thing is what you can do is you can save your scripts so you can come back at a later moment and continue where you left off. I also created my polymorphic table function here, so for you guys to check it out, so you can find my my piece of code. Another thing in LiveSQL is the quick SQL. Well, Notepad. What you write in shorthand is the table name and then the columns, varchar 100, etc. And what it'll create is the entire script on the right side. If you don't want to use SQL, LiveSQL, you can always try to use the new free tier database. So what I did was I started playing with the polymorphic table functions. On the LiveSQL, I created a Tom and Jerry table. I inserted the 3 rows where we had Tom, Jerry, and Spike, and the 3 speaks they had, the 2 languages they spoke. And then I had to create a polymorphic table function package. This function has at least the describe procedure. That's the only one that's mandatory. What you do in the describe function is you in the describe function, there are 2 parameters: the table name, or the table type actually, and the columns you want to see of this table. And what I'm doing in this describe, I'll go over all the columns in the table, and for every column in the table, I'm looking into the columns that I sent in, and if they match, I'll give it a pass through. I'll say show it in the result. And when found when it's in the result, then I can execute that loop and go to the next one. Then I have to create a wrapper function for the polymorphic table function, and the wrapper function will return a table pipeline row polymorphic using the package I just created. So now I can say select start from my function, the Tom and Jerry table, and the columns I want to see, name and English. Calling the exact same function, exact same table, but this time with the columns name, English, and Dutch, it'll show me those 3 columns. When I insert the extra row, the little quacker, into the table, I can call the exact same SQL statements again, and it will show me the new row in both cases, both English and Dutch. We could do that with the normal table functions. If I alter the table to reflect Spanish, and I set the column to show it the correct words. If I then select the same columns from the table, it will still give me the correct result. If I select the new column, it'll show me the new column as well. I didn't have to recompile, I didn't have to change anything. I can even create a table called numbers with the name, English, Dutch, and Spanish versions of it. And if I then select my function, Tom and Jerry speak, not a good name for a function, but it is what it is, I can get the correct result. So I'm using a completely different table with actually in this case pretty much the same columns, but they don't have to be the same. And if I select everything from Tom and Jerry again, it also still works. What happens a lot in my current assignment is I get separated lists. And if you have a separated list of these characters, they might be separated by semicolons or slashes or commas. And the number of fields are different every time. So what I want to do is I want to create a polymorphic table function that selects these the individual columns from the separated string. So I create a polymorphic table function package again. I have to create a describe function. In this describe function, I'll mark the first column as read only, and I don't display it anymore. So it's for read. I have to read it, but I will not pass it through. And then in the second part, I'll loop through all the columns in the columns parameter, and I'll define new columns for all the names, and just make them a length of 4,000, far cry to 4,000. And then at the end, we'll return all the new columns. And in the fetch rows procedure, I want to know which column I want to split. In this case, it's the first column of my of the table. And then for the entire row set, I'll go split every row into the different separated values using a regular expression. And then I just return the newly populated columns in the rows. And of course, I need to create a wrapper function for this table function. And this is what I used to do. Write the regular expression over and over again, and then just change this third or fourth parameter. And what I can now do is select using the table function. And if I want to display more columns, I can just add more columns to the list. If I want to display just the first and second, it will show me that. A friend of mine said, hey, you are always looking for use case for polymorphic table functions. Why didn't you build a sum interval function? And I figured, that might be a nice use case for table semantics, polymorphic table functions. What we just saw was row semantics. Everything we were doing could be done on the data of a single row. In this case, I need a sum function, which is the sum over the entire table or result set. So I started building a table, table intervals, and you got two interval types, interval year to month and date to second. And I added some data to just to show that the data is in there. And then I tried to do a select sum of the year to month interval to see that it doesn't work. And just to make sure that you can add these individual values, I did a select from different intervals. And yes, it can be done using the separate intervals and then adding them up by hand. Same goes for the data second intervals. You cannot select the sum of it, but you can add them up yourself. So what I was going to do is I went out and created a new package. In this case, a sum interval polymorphic table function package. In the describe function, I created a record to hold the sum values. And after that, in the describe, I mark every column to not be passed through. We're just interested in the sum columns. And we'll mark every column not to be read unless we're interested in the result. And if we're interested in the result, then we'll mark it to be read, so for read is true. And we add a new column, which has the same name as the original column, except it's prefixed by some underscore and suffixed by an underscore. And then after we return that, I created a variable to hold the environment. I want to check the environment a couple of times, so it makes sense to do that just once and hold that in a variable. And then I have to create variables to hold the year to month and the date to second interval sums. And then in the fetch routine, we go through every column in the table, and we're going to check if it's a year to month type. And if it's a year to month type, we'll get the entire column and we'll initialize the record value. Otherwise, you'll add something to null, and it will result in null. And then we look through all the values in the column and add them together. And for the date to second type, we do pretty much the same, but this is a different data type, so we have to do this separately. And if there's anything else you might put in there and we cannot do anything, we'll just display an error showing the column of this type is not supported. And then at the end, if we've done all the summing, we'll just completely ignore the current row set. We're not going to show that anymore. And we're going to start a new row set and we'll just show the totals. And if we're giving that back, we also, of course, we need to create a wrapper function, some interval. In this case, it's pipeline table, where the other one was pipeline row polymorphic. This one is pipeline table polymorphic using the function. Again, I show you the select sum doesn't work, but if we do that using the new function with the polymorphic table function package behind it, we'll get the correct result. And for data second, same issue. We'll select the data second, doesn't work, and if we do that over the function, it does work. So if you want to learn more about this, go to my blog for 2 articles on the polymorphic table functions. And you can also go to LiveSQL, where I've created the table functions for split column with a variable column name, and even with a variable separator. And that's just about it. Any questions? Are there any questions? I don't see any questions coming up. It's my well, if there's no questions, I'm a bit ahead of schedule. But then, thank you for your time.